Thanks everyone for coming to DEV335, Manage Infrastructure Securely at Scale and Eliminate Operational Risk. My name is Anant Vaidyanathan. I'm a Senior Product Manager on the AWS Systems Manager team. I'm also excited to have Daniel Koo with me here, who's a Senior Director at FINRA. And in this session, we'll talk about key enterprise IT management problems that you may face in your environment, both on AWS or EC2 and in your on-premises, and how AWS Systems Manager can help you solve those problems securely and efficiently. I'll also then hand it over to Daniel, who will talk about how FINRA already uses Systems Manager in their production environments and how they plan to scale their usage of Systems Manager even more. I'll also demo how you can use AWS Systems Manager to solve key enterprise IT problems, and so will Daniel. And finally, I'll wrap it up by giving you best practices on how you can get started with Systems Manager, and then we'll leave some time for questions as well. So in this session, I'll cover 4 key enterprise IT management problems. The first one is to make configuration changes securely across groups of instances, while at the same time adhering to corporate security policies that increasingly mandate that machines be locked down. So that's a problem we're going to talk about. Next, how do you get a holistic view of what's actually on your instances? You have groups of instances across your accounts, across regions, and there are tons of applications, there's a lot of software on those instances, and you really want to keep track of what's on those instances. Next, patching. It's a major pain point for a lot of you, I'm sure, and patching traditionally has been a very inefficient, inexpensive, and a very laborious process, and Systems Manager will help you solve that. And finally, storing and retrieving secrets. As you increasingly move towards maybe an infrastructure as code environment, a more DevOps environment, you want to separate your secrets from code and securely store them. And there really is no easy way to do that today. So we'll solve that problem as well. So we heard all of these from customers, and we recently launched AWS Systems Manager. And what AWS Systems Manager essentially is a unified interface that centralizes operational data from multiple AWS services and automates tasks that you can perform on your resources. So it does this in 3 ways. First, it allows you to group resources into logical entities that represent an application. It then allows you to visualize operational insights and get insights into those resources so that you can see operational insights. And finally, it lets you perform actions on those resources, take operational actions on those resources. Many of you may already be using EC2 Systems Manager or SSM. You might already be familiar with that. AWS Systems Manager brings together all the SSM services that you already use and know so far, and it adds new capabilities that allow you to group and visualize, and across multiple services. So it brings together a complete unified interface to do all of that. So which means you get all the 3 benefits that you can see on the right-hand side as well. It's cross-platform, so we support a wide variety of Windows and Linux operating systems and distributions. It works on AWS as well as on-premises, so if you have hybrid environments. And it natively integrates with AWS services that you already use, such as IAM, CloudTrail, config, and I'll talk about that as well later on. And finally, it comes at no additional charge. So you only pay for other AWS resources that you will usually pay for, such as EC2 instances. You don't pay for systems for using Systems Manager per se. So with that, I'll get into how you can solve those 4 key problems that I talked about. How performing safe and secure operations on instances with full visibility and auditability, understanding what's on your instances, simplifying and automating your patching processes, and centralizing secrets management. So the first one is safe and secure operations. So as I mentioned, increasingly customers want to lock down their machines, shut down inbound SSH ports, say port 22, or in the case of Windows, say port 3389, and they want an audit of every command that's run on an instance. At the same time, you may also have bastion hosts or jump boxes that you use to SSH or get into instances. So that adds an additional level of complexity to your infrastructure. So with Systems Manager, you get rid of all of that. There's no more SSH, there's no more bastion hosts, but you get, and in addition, you get role-based access control. You can control exactly who can perform actions on an instance, and you have full auditability into what actions were performed by a user and when, which you would never get with regular SSH. At the same time, you can perform these actions at scale. So no longer do you have to log into each and every instance if you want to make a change, such as say, stop a process across tens of instances, for example, right? You can do it across groups of instances. At the same time, you may have, for example, inadvertently, let's say, make a configuration change across hundreds of instances, and you may want to stop that before it propagates through your environment. So we allow you to safely perform those operations as well using rate control. So which means if you have groups of instances, you can run commands in batches and set error thresholds so that once if a command fails, for example, when it breaches the error threshold, it immediately stops. So you can safely ensure that changes are propagated through your environment. So this is a quick example of being able to run a command. So you can everything is logged through CloudTrail. You can receive notifications as well. A quick CLI example, it's very easy to get started. The command that you run command uses send command API. So it takes a few simple parameters if you wanted to get started. It takes a document name, which is essentially a configuration that lets you codify and automate your IT processes. It takes a bunch of targets. Targets could be instances, or it could be tags. So if you have instances that have multiple tags, for example, you can do that. So in this example, I'm saying run a health check on all instances that are in my dev or production environment, but they have a tag that says, with a role tag that says web frontend. So it's a mix and match of tags. It may resolve to a specific set of instances. I also added rate control, which says that run them in batches of 10. So let's say that this is resolved into, say, 100 instances. It would run them in batches of 10. And if at any time you breach the error threshold of 20, as I've mentioned there, it would stop. So you prevent say, changes from propagating. I can also provide this in percentages. So I can say 10% and 20% as well, in case you don't want to provide absolute numbers. You can also receive notifications as soon as a command fails. So let's say you want to install an application on an instance and on, say, tens of instances, and for some reason something fails, you can immediately get a notification or trigger a CloudWatch event. So you can receive an email or trigger another run command or a Lambda function to perform appropriate actions if something fails. Typical use cases that we've seen customers use run command for are making registry edits, installing applications, taking VSS snapshots, something that we announced very recently, especially for Windows customers. It was a major ask. So you can take VSS snapshots using run command as well. And you can perform system monitoring. Speaking of system monitoring, it's been a major ask from customers to be able to get in-guest metrics and logs in a very simple and easy manner. Till now, it was a very fragmented experience. For example, on Windows, you could still use SSM to collect metrics and logs from Windows instances. But for Linux, you needed the CloudWatch logs agent. You needed to install Perl script and use the collectd plugin. So it was a very fragmented experience. And so we are excited to pre-announce instance health monitoring with Systems Manager and Amazon CloudWatch. So now you can collect metrics and logs from Windows and Linux instances using, say, run command or state manager, push them to CloudWatch. Examples of metrics could include CPU, memory, disk, network. In the case of Windows, custom metrics such as other performance metrics that you might want to collect. You could collect that at sub-minute granularity as well. Logs could include any Windows Event Viewer logs and other system logs as well. All of this goes to CloudWatch, and you can customize aggregations there as well. So you can set up instance level aggregations or fleet level aggregations as well. Finally, all of this will be open source. The plugin that we'll use will be open sourced as well, just as the SSM agent already is. So the SSM agent, as you probably already know, is open sourced and it's available on GitHub. And so will this new plugin that you will use as well. Just another quick thing that I wanted to talk about is a role-based access control. As I mentioned, you can control exactly who has access to what instance and have an audit trail. So in this case, if you look at the IAM policy there, I'm for a particular user that you could assign. I would say that user can only run a command against instances against web servers that have the tag app web server, and he or she can only run a configuration or a document that has a tag, that has an appropriate tag to configure the web server. So literally that's about it. If the user tries to run a command on any other instance, it would fail. So which means if you think about it, you have no SSH, and you can actually control what commands are run and have them audited as well. So this completely automates as well because it's completely tag based. So as and when new instances come in, you don't have to update the policy. I'll also show you a demo later as well. So it's a completely buttoned up environment. So just getting into documents as well. So documents let you codify IT tasks. Previously, you could author documents only in JSON. Starting yesterday, you can now author documents in YAML as well. In addition, you can Systems Manager as a platform. You can run additional. You can bring in your existing tools as well. So whether it's Python scripts, Ruby scripts, Ansible playbooks, and all of that, you can directly run them as well from say public or private GitHub repositories or S3. So it makes things really simple. You can also centralize and standardize configurations. So you can have a single master account, for example, that has a set of documents. And then you can share them across accounts, and using the permissions that I mentioned, those sub accounts can only use specific documents that have been assigned to them through tags and access control and all of that. It's also cross-platform, as I mentioned, so it works across both Windows and Linux. So here's a quick example of a document. So a document has a schema version. It has a series of actions that are run. The first action, as you see, installs Apache, but as you may notice, there's no code to install Apache. It references another document, so which means you can easily refer documents. It enables modularity and reusability. So you can have a bunch of smaller documents to install Apache for process management and make changes on that, while having a central document that simply makes references to that. In the second example, I'm actually referencing an Ansible playbook from my private GitHub repository. I also have my access token that I've stored securely in parameter store as a secure string, as a secret. And then I've downloaded the Ansible playbook, which installs Nginx on my instance. And in the third step, I'm just running the playbook on my instance. So literally, I've done like 3 things here in very simple YAML. So we solved problem 1. So next, we're going to look at how Systems Manager gives you insights into what's actually on your instances. So with Systems Manager inventory, you can collect software inventory using we have predefined types such as applications, files, Windows Server roles, network information. Once you collect that information, you can query that information. Say, for example, you can say, show me all instances that have Chrome 62 installed, for example. You can create a data lake. And then you can also track changes to what's on your instances. So for example, if you had a piece of software that was updated, say, a week later, you can keep track of those changes on your instances. In addition to these predefined types, we also have custom inventory. So depending on your business needs, you can create custom inventory types based on your schema. With Systems Manager, you now have insights on the dashboard. You can see top 5 services. You can see new aggregations as well. And we also integrate with AWS config. So if many of you use AWS config, all inventory information is pushed to AWS config. So you can see a historical record of changes of inventory changes on your instances. So that's pretty cool. And finally, a big ask from customers is to be able to get inventory information across regions and accounts. And as I'll show you, you can use resource data sync to push inventory information from multiple regions and accounts into a single S3 bucket, and then be able to query or visualize all of that information. So you can say, oh, show me all instances that have some version instances across all accounts and regions that have some version of middleware installed, for example. So just to quickly recap, we looked at solving 2 key problems: safe and secure operations without SSH, using SSH or Bastion hosts without run command. We looked at how you can use SSM inventory to get a holistic view of what's on your instances. Next, we'll get to patching. As you know, patching, as I mentioned, is a very laborious process. It's very expensive. With Systems Manager, we have completely automated that. We have simplified it quite a bit. And so what you can do with patching is create rules that define what kind of patches need to be applied and how long they can, what kind of patches that can be applied and how long you can wait before they can be applied. You can decide when to install those patches. For example, obviously you don't want to install patches during business hours, so that doesn't impact your applications. So you can run them during maintenance windows outside of business hours. And finally, you can view patch compliance, which is really important for security teams to say, hey, show me all my instances that aren't compliant with the rule that I just defined, right? And I'll also show you how you can get patch compliance across regions and accounts as well. So you can say, show me all my instances that aren't compliant with the rule that I defined, or that don't have this particular package or this KBID installed across regions and accounts. So this is a quick example of what a patch rule looks like. It's a patch baseline, and it has a bunch of rules. It has a product classification, which means a number of critical updates, security updates, and all of that. You can select what kind of severity of the updates. In this case, it's Windows. The same thing would apply for Linux as well. Auto approval delays, which is pretty important. Auto approval delays essentially means the number of days you need to wait before the patches are automatically deployed. So for example, what that means is when a patch is released, for example, you don't want to apply the patch immediately. You want to wait some number of days for your security team to vet the patch, for example, and they give a green light before you actually apply. So in this case, I've given an auto approval delay of 2 days, so which means it's pretty short, but it gives 2 days. It waits 2 days before the patches are actually deployed. And you can set an appropriate compliance level that according to your business needs. You can also provide approved and rejected patches. So in this case, I've explicitly added a particular patch that needs to be installed. And on the right-hand side is a compliance summary that you can see based on the patch rule. So you can say, oh, non-compliant instances, and for the number of non-compliant instances, you can see the patches that are missing, packages in the case of Linux and patches in the case of Windows that are missing. And finally, the fourth problem is storing and retrieving secrets. So increasingly, you're moving to configuration as code. You want to separate out your secrets from your code, but there really isn't any way to do that. With parameter store, you have a hierarchical key value store to store your secrets. These secrets could be API keys, they could be database passwords, domain join passwords, for example. And you can store them in hierarchies based on, say, a dev, test, prod environment, so you have first-class support for hierarchies. You can provide access control. So you can say, hey, this is a developer. He or she shouldn't have access to any production passwords. So any secret that's in a production hierarchy, say /prod*, and that person can never get the value of that. So you have granular role-based access control. And you have an audit trail as well. So you can see exactly when a secret was created, when it was used, and so on. And you can easily programmatically retrieve those secrets and use them across AWS services. So for example, typical use cases include secure environment variables in code build, using passwords across Lambda functions, for example, or in ECS task definition. So these are some a non-exhaustive list of places where you can use these secrets. So with that, I will quickly jump into a demo and show you how you can actually do some of this. Oh, just give me a second. Okay. So just to quickly set the context, I'll first navigate to the EC2 console. I'll select an instance, and I will show you that I, in fact, do not have SSH enabled on this instance. So there's no inbound SSH at all. So with that in mind, I will now switch over to the new AWS Systems Manager console, which you will find under Management Tools, right here. Right. So I will come here, and then I go to managed instances. And let's say for a simple example, I'll say I want to install Chrome on my instance. And remember that I don't have SSH access. So I'm now an admin. So I can just go, I can say run a command. And I have a few documents that I've created already. So in this case, I have a simple document that installs Chrome. I have a couple of other documents that check if particular ports are open. I have admin-only documents, one that terminates Apache on an instance, another that deletes files. And I have a document that lists all processes by CPU or memory usage. So in this case, I'll quickly install Chrome, right? And then I can specify a tag, but since it takes a little time, I'll select web server. Remember, web server is the one that doesn't have SSH enabled. And then I can also specify a RAID control. In this case, it's just a single instance, but so I won't use RAID control. But in any case, I can use targets and percentages, right? And I'll quickly run this. Okay, I don't have to select that. Oops, just give me a second. Install, I got Chrome, select the web server, and I will just run it. And then let me go back, since this takes a little time to install. So I already just ran it, already. So you can see that it was successful, it ran. The other interesting thing that I want to show you is now I have an audit as well. So CloudTrail, I've set up a stream, a log stream to CloudWatch, so it just makes it easier. And let's say that I open this, and then if I open this, as you can see, this was a slightly earlier thing, but as you can see, it just said I ran the install Chrome document, and it says which instance I ran it on, and what API it was, and it also gave me the ARN and the user as well. So now it gives you complete auditability into exactly who ran what command and when, right? So this is a simple example. So now the other thing I want to now show you is delegated administration. As I said, you can do role-based access control. So I'll go to IAM, and then what I've done is I've created a restricted user. So let's say it's somebody in my team, right? I've created a restricted user. I've created a policy here. And in the policy, if you see, I've allowed run command access only to instances that, only to my web server instances, so that have the tag of the web server. And I'm saying that this restricted user can only run this particular document. I can also provide a tag as well for the document, but in this case, I've kept it simple and said that this user can only run this document. And if you remember, this document shows you the number of lists of processes in decreasing order of CPU memory utilization. So if you come here, I can actually show you what that document looks like. And if I go content, it's a very simple thing. I was a little lazy, so what I decided to do was I just wrote a simple bash script, put it on my GitHub repo, and I just made a simple reference to my GitHub repo instead of writing a full JSON or a YAML. So I just made it very simple, and I stored my GitHub personal access token as a secret in parameter store. Right? So now let me go back and log in as the restricted user. So now if you see, I've logged in as a restricted user there. So let me now try to see how this works. So go here. Oh, sorry, there it is. Now close this. And I say run command. And in this case, I can see all the documents as a restricted user. Let's say I want to be a little fancy, and I want to say, hey, let me terminate all the Apache processes on my web servers, right? I'm trying to see what I can do. I'm trying to be a little fishy here. I say run, and it stops me. It says, hey, you don't have access to this document. So now I say, okay, fine. Let me say, let me change the document. Let me use the document that I have access to, which is get processes. Say, okay, well, let me see what are the running processes on my production server, right? I say, okay, fine, let me run. And it immediately says, hey, you don't have access to that particular instance. So in the first case, you don't have access to the document. Now you don't have access to the instance. The reason is I have the restricted user, rather, has access only to web server instances, not to production server. I'm like, okay, fine. So now let me just do what I have access to. And I say I selected that, and then I just selected the web server. So in this case, these are the two things that I have access to. And I say run, and then it runs. And I go here, and I can see all the list of processes by percentage of memory and CPU. So quickly, as if you can recollect, just to recap, I showed you delegated administration, how I created a less privileged user, gave that user very scoped permissions. And now if I went to CloudTrail, for example, I could see exactly that this user ran this particular document, for example. So this was how to do safe and secure operations. So now I will switch to patch, which I'm sure is a big use case for a lot of you. So patching, the first thing that you want to do is create those rules that I mentioned. So these are called patch baselines. Out of the box, we have patch baselines for the operating systems, Windows, Ubuntu, Red Hat, and Amazon Linux. Basically, these are standard baselines that install the appropriate packages or updates. However, I've created my own patch baseline. In this case, I've created them for my web server here. And then I've gone to and then I've created two rules there for my Windows Server 2012. I've critical updates. I've said wait 3 days before approving them. Don't just do it immediately. And I've said this is critical for me. And I've created a second rule that says security updates. Wait 1 day. That's fine. I think 1 day should be enough. I say this is high. It's not critical, right? And I say I've run them against a set of patch groups. And a patch group is a set of my web servers, right? Now, I've also created a second patch baseline for my Linux instances, for my Linux web servers. So the same thing here. This is for my Amazon Linux. I've selected all the Amazon Linux versions. And in this case also, I have done web servers. So my web server tag actually has both Windows web servers and Linux web servers, right? But I've still created two patch baselines. So the cool thing with Patch Manager is that it when I run this task, it automatically applies the appropriate Windows patch baseline to my Windows web servers and the Linux patch baseline to my Linux web servers. So it does that automatically. You don't have to worry about that. Now, there are two ways that I would run it. One is typically you run it during a maintenance window outside of business hours. So here I've created a weekly maintenance window. I go here. I've created to run every Sunday at 12 p.m., which I think is a good time to do patching or any other operation. And I've set my patch task to run during that maintenance window. So this is one way that I would normally do it. Suppose there might be another time when you want to say when you have a 0-day vulnerability and you want to quickly patch all your instances, right? A new patch has come out. You don't care that you want to do it outside of business hours. You want to do it right now. So in that case, I could quickly go to run command, for example. And I would say run a command, and then I would say, sorry, not this. I would say document name. And then I would say run patch baseline, for example. And then I would say, hey, just run it on all my instances. So what that would do is take the default patch baseline and run it against all my instances. And just as I said, I could still do rate control as well. So even because I'm doing outside of business hours, I don't want to do everything at the same time, right? Even though it's a 0-day vulnerability, so I can set up rate control so that it does it in batches. And if, for example, if patching fails, then it would stop. So some sort of safety there. So this is how you would apply the patch. And the third thing that you obviously want to look at is compliance, right? Patch compliance. So now I go to compliance here, and then I select patch, and then I see 3 non-compliant patches with high severity and some with unspecified. The reason some are unspecified is because I ran a 0-day vulnerability check against all my instances. Some of them weren't part of a patch group, right? So I just ran it across all my instances. They didn't have a compliance level associated with them because they didn't have a patch baseline, right? So I just passed them. I ran a scan against all instances, right? So this is a big ask from customers was, can I see patch compliance across all my accounts and regions? The answer is yes. So I would go to inventory here, and I can say resource data sync. So what resource data sync does is that it pushes in all inventory information across regions and accounts into a single S3 bucket. And all compliance information from SSM is part of the inventory as well. So I would select this, and then I've created an S3 bucket. Very nice name there. And it's in the US East 1 region. So this is not even in the US, actually in US East 2. So I've created in the US East 1. And if I want to do this in different regions or accounts, all I would do is just create a resource data sync in each account once. This is a one-time thing, and then it automatically syncs inventory every time. So it says, as you can see, the last successful sync was done earlier, just now, I think, based on UTC. So it would do that. And then if I go to, say, QuickSight, I can now get a holistic view of patch compliance across the regions and accounts. So I've created a quick dashboard here. It might take a little time to load. Yeah, I can do with better color coding, but essentially you can see 2 regions, a very simple example, and I can see that, hey, I have 5 non-compliant and 4 compliant in US East 2. If you remember, it matches with the information that we saw on the compliance screen. And this is in US East 1. I have 3 compliant instances. So this is a very simple visualization, but you can see how powerful it is, because now you can now see patch compliance across regions and accounts. I can do a lot more slice and dice, but this is a very simple example. So this is how two of the 4 problems that I talked about. And with that, I will switch over to Daniel, who will talk about how FINRA uses Systems Manager in their production environment.
Right, thanks, Anand. So first of all, it's great to be here at reInvent, and I'm very excited about to share what we have done at FINRA. So again, my name is Daniel Koo. I'm a senior director at FINRA. I currently oversee the DevOps engineering practice. So my group focuses on building products and tools and solutions to enable our development teams to practice DevOps and continuous delivery. So a quick introduction about FINRA. So FINRA stands for Financial Industry Regulatory Authority. We are a regulatory company overseeing the broker-dealer industry. Our mission is to protect investors and promote market integrity. So some numbers about FINRA. So we monitor 12 different markets and exchanges, right? And we regulate more than 3,800 different brokerage firms. And we regulate more than 634,000 brokers that are working in US. On average, we would collect 37 billion events, right? That's how much we ingest, and that's how much we analyze per day. So in terms of our technology footprint, as I mentioned before, we ingest enormous amount of data, right? And we can get up to 75 billion events per day. In terms of our storage, we have more than 20 petabytes of data that are being stored in AWS. And when we reconstruct our market data, we can get up to trillions of nodes and edges. So you can see how complex our data could get. And every day, we run hundreds of complex queries to be able to detect fraud and any wrongdoings that are happening within the broker industry. At any given time, we could be having 5,000 plus running instances. And within our portfolio, we have more than 150 different applications that are running to operate our business. So by nature of our business, we are a big data company. We heavily rely on cloud computing, cloud technologies, and big data technologies. So now moving on to the problem space of managing infrastructure at scale. So FINRA being a regulatory company, we pay very close attention to compliance, audit, and security. And the amount of data that we get, and some of them which are sensitive, it is critical for us to stay compliant and have security in place and be able to scale, right? So we need to put proper governance in place. We need to put proper control in place. And we need to have right level of transparency into what is really happening in our infrastructure, right? Who's trying to access what? What are they trying to do? So we need to have these type of transparency. Another challenging fact is cloud being a transient platform. You know, we have a lot of short-lived instances, right? Many instances can come up and down at any time. So having visibility into these type of infrastructure, it is challenging. And lastly, we want to follow the modern DevOps methodologies, right? Automation and self-service model. So putting all this together, it is not that easy to manage an infrastructure at a big scale. So in this session, I want to talk about two different solutions that we have built using the systems manager. So the first one is called Gatekeeper application. So this is a homegrown web application that we have built and we have deployed into production that we've been using for a couple of years now. It is essentially an EC2 access management system. It grants temporary access to EC2s. And it's a self-service model with an approval process in place. The other solution is called the Rundeck SSM plugin. So Rundeck is an open source tool that is used to run operation procedures across many of the running instances. So we use Rundeck for running our ops jobs. So we wrote a plugin on top of Rundeck, right, to help us to run our ops jobs across fleet of instances in many different accounts, regions, and environments. And we wanted to use SSM so that we can eliminate the need of SSH. So diving into Gatekeeper, this is the user workflow of Gatekeeper. So the user will open up the application on their browser. And what they're going to do is they're going to search for the instances that they are interested in gaining access. Right? So they're going to search for their instances, and once they identify, these are the instances that I want to gain access to, they're going to make a request. In their request, they're going to say, please grant me X number of hours. Typically, users would ask for an hour or two to troubleshoot something that's going on their server. And this will notify, once you make the request, it'll notify the approvers, right? And they will get the notification, and they'll go through the pending request and decide whether to approve or reject. So let's say they approve, right? Once they approve, this is where SSM kicks in. So we run an SSM document on those instances. So what it will do is it will go and create a temporary user on those boxes, and then the application will send the SSH key, the PEM file, to the requester. Now the requester can use this PEM file to SSH into the instances and do what they need to do. And then once the request expires, then SSM gets kicked in again, right? So this is where we will go to the instances and remove the user from those boxes. And then the requester no longer has access to that EC2. So here's a snippet of our create user SSM document. It's a very simple Linux shell script. It's a parameterized document, so you can pass in different parameter values when you execute this document. We have a similar document written for Windows as well, written in PowerShell. Here is the snippet of the remove user document. Again, it's a shell script for Linux, and we have a similar one for Windows as well. So talking about the benefits of having Gatekeeper, right, when we compare before and after, the top benefit is better security posture. Before, we used to share the SSH keys across many different users. And we would also have permanent users baked into our custom AMIs that we create. So it became a management nightmare. When we have new people or when people leave, we will have to manage and make changes to the custom AMI. So this was definitely a difficult thing to manage. Now with Gatekeeper, everything is temporary. So it's all short-lived temporary users on the instances, no need to manage these users. And once the request expires, then even if we share the SSH keys, then the users don't have access to the instances anymore. We get maximum transparency. We know what is happening. We know who's asking for requests, for what reasons, right? So we have an audit trail of who's accessing what instances. It's very fast, reliable, and everything is automated from end to end. And also, it's very cost-effective. SSM is free, and we maintain the product, and that's all we need to do. So now moving on to the next solution, the Rundeck SSM plugin. This is the high-level architecture diagram of the solution, and you can see that SSM plays a central role in the solution. SSM is basically the communication gateway between the Rundeck server and our instances that are running across multiple different environments. We also leverage S3 for storing arbitrary data and scripts for SSM to use to execute on these instances. So there are two main ways of running the scripts or commands on these instances using the plugin. The first way is, let's say you want to run a command or a script that's already staged on the instance. What will happen in this case is Rundeck will provide instructions to SSM, right? And send a list of instances that you want to run against. SSM will take those instructions via an API and it starts executing on those instances. And when it's done, it collects the results and sends it back to Rundeck. The second way of executing is you want to run an arbitrary script that is not staged on the instance. So in this case, what will happen is the plugin will stage the script onto S3, and then again, it'll send instructions to SSM. Then SSM will start executing on those instances. The first thing it'll do is it'll download the script from S3 and starts executing. And when it's done, again, it'll send back the results so that Rundeck could have a track record of what happened. All right, so benefits. Again, better security posture, right? We don't need SSH keys. Everything is handled by IAM policies, right? So it's much, much secure. Also, in terms of network topology, it is much, much simpler. Before, we will need to have firewall rules set up, security group rules set up from the ops tools to talk to a lot of instances that are running across different environments. Now, the only thing that's needed is access to SSM and S3. So it's a much simplified network topology. It is highly scalable. Whenever we add new accounts, new environments, all we need to do again is to just configure our IAM policies and you're ready to go. Very fast, very reliable, and low cost. Rundeck being an open source tool, we need to maintain the plugin, and that's all we need to do. So some things that we are working on now. We're looking at parameter store for managing our secrets. It has a very good integration with existing AWS services. So we're looking at that more specifically around our deployments. We're also looking at parameter store for ad hoc fetching and storing of secrets using API. We're looking at state manager for performing configuration management on our Windows servers, as well as collecting compliance report and performing auto remediation. Lastly, patch manager and automation. We're looking into this to perform ad hoc patching against running instances for critical vulnerabilities, as well as collecting compliance report. So now I would like to show a demo of Gatekeeper. And I have a pre-recorded video because otherwise we'll be waiting here for hours for the request to expire. So I'm going to show a case where I'm going to make a request and go through the approval process and then logging into the instance using the temporary key and the expiration. All right, so this is a landing page of Gatekeeper. So when you get here, you get to choose between EC2 and RDS, all right? So I'm going to go ahead and choose EC2. Now, once I do that, I get to see two different panels. One, who needs the access? So here you can actually search for somebody else, or you can click Add Self to request from me. All right? The next thing you're going to do is you're going to search for the instances that you are interested in gaining access to. So you choose your account, your region, the platform, and there are multiple ways of searching for these instances. So I'm going to go ahead and choose name and type a string, so GTK-PR, and click on search. Now what it's doing is it's going and looking for these instances that are matching that string. And once we identify, we're going to select whichever instance that you want to gain access to. So we're going to go ahead and select the first one. And at the bottom, you get to see the information about this request. So who's trying to access to which instance. And at the bottom, you're going to choose for how many hours you want to have access to. So we're going to click 1 and click request. Now, when you do that, you need to provide a reason. So this is for audit trail purposes, right? So we're going to type in the text. This is the reInvent demo. And we typically open an incident whenever we have issues with our servers. We're going to put our ticket number there, and then we're going to click yes. So when we click yes, what happens next is it sends a notification to the approvers. Okay, so they can take a look at it and make decisions of whether to approve or deny. So here is the screen for the approvers. So I logged in as an approver. I get to the same landing page. I'm going to click on the EC2. Now I'm automatically landed onto the pending access requests. As you can see, there is one pending request that was just made. And when I click on it, I want to see the same details that I saw when I made the request. So Stephen Mealy made the request for one instance, as you can see the reason as well. So now approver can make a decision. So I'm going to type comment. So you are approved to debug this instance for the next hour. So after that, I'm going to click approve. And when I click approve, this is when SSM gets executed. All right? It runs the SSM document on that instance to create a temporary user on that box. So let's see what happened in AWS console. So we're going to go to the run command, and we're going to search for that instance. And when we do that, you can see a record of the document getting executed. The GK create document was executed on that instance. Okay? And you can see that it was requested at 2:45. And on the right side, you can see the parameters that were passed into the document as well. So the username that was generated by the application, as well as the public key that was generated by the application, was passed into the document for execution. And you can see that it was successful. So now we're going to go back to the requester screen. And what you're seeing here is 2 emails that get sent once the approval happens. On the right, you get to see an email with the username and the instance that the user has been granted. On the left side is an email with the temporary PEM file that you can use to SSH in. So we're going to go ahead and try to log on to that instance using that PEM file. So I'm going to type SSH, point to the PEM file, and use that username that was provided and the IP. So the username matches the user's network ID. So there you go. Now the user has access to the instance for the next hour. So let's see if the user directory has been created. So you can see that GK-MEALYES directory has been created. And we're going to run the ID command to see that the user has been added to the box. So there you go. Now you can see the user is added to the box. Now, what we're going to do is we're going to fast forward 1 hour, okay? So we're going to fast 1 hour and show what happens when it expires. So now, the requester receives an email after an hour saying, your access has been expired. So let's try to log on to the instance again using the same key. Again, same pen file, same username, and same IP. And now it prompts for password. So you no longer can use this key to access the instance. So now on a different tab, we already logged in to the instance using a different key. We're going to show you that the user has been removed from the instance. So we're going to list again the home directory. And now you can see the gk-email.es directory is gone. And we're going to run the ID command again. And it'll say no such user. All right, now let's see what happened in AWS console. So again, we're going to go to run command and search for the instance. And now you're going to see 2 entries. The first, the one we already saw, gk-create. Now the next one is the gk-delete. You can see that it was executed at 3:45, exactly 1 hour after it was requested and approved. You can see that gk-email.es parameter was passed in to this document and that it was successful. That's the end of the demo. So one thing I want to mention is we are going to be open sourcing Gatekeeper and the Rundeck SSM plugin next year. So please feel free to check it out. So I'm going to hand it over to Anand.
Thanks. Thank you, Daniel. That's really good. Really excited to have FINRA using Systems Manager. So just to quickly recap, a few things that I'd like to quickly highlight. It was a big customer ask to be able to use Systems Manager services in VPCs. And so with AWS Private Link that was announced not so long ago, we now have, you can now create VPC endpoints for Systems Manager. So now you can imagine that you don't even have SSH access, and at the same time your instances are isolated within a VPC, and now you can easily say remotely administer them, collect inventory, and do all of that from isolated instances. The SSM agent, as I mentioned, is open sourced. It's available on GitHub. We generally recommend that you update the agent every month, just because the rate at which we push out new capabilities and features, you're always up to date with all the new things that come up. The SSM agent is installed by default on all the Windows Server AMIs and the Amazon Linux AMI, and it's also available on the Amazon Linux repo as well. Finally, it natively integrates, as I showed you, with all AWS services. So that's really important when you think of a management tool with all the services: IAM, CloudTrail, Config, KMS, CloudWatch, and all of that. So finally, to learn more about Systems Manager, you can go to our marketing page. Specifically, I'd like to point out the 2 links there, on the AWS blog and the management tools blog. So these are categories where you can see all the blog posts that we have written over the past year or so. It provides a wealth of use cases and walkthroughs that will easily enable you to get started with Systems Manager. We also have another session tomorrow at 9:15 a.m., DEV336, where we'll talk about how you can use Systems Manager in a more DevOps fashion. So we'll talk about some of the other services within Systems Manager as well. So highly recommend that you attend tomorrow's session at 9:15. And feel free, if you have any feedback, any new features, anything that seems different, feel free to send us an email and we'll take a look at that as well. So with that, I'll end the session here. We have some more time. We have our Senior Engineering Manager, Amjad, as well here. So we are happy to take questions. I'll just drop by outside the stage, and feel free to come up and ask any specific questions that you may have about Systems Manager. Thanks a lot.